Hello again. In this section we're going to look at the containers which are provided with the C++ standard template library. These are data structures which have been designed, coded, tested and debugged by some of the best developers in the world. They're very safe, very reliable, very efficient and very useful, so you should certainly know about these and try to use them wherever possible in your programs. We've actually already been using some containers without really making much fuss about it. We've used standard string, which contains a sequence of char objects which make up the characters in the string, and standard vector and standard array, which store a sequence of objects of the type that the vector or array is specialized for. We're not talking about the C-style array here because that's not part of the standard template library. This is the standard array which has a template parameter. So all these containers store data as a sequence, and for that reason they are known as sequential containers. The other main type of container in the standard template library is the associative container, and these are called associative because they associate pairs of data items. So for example, we could pair up someone's name and their address. We could pair up an employee's payroll number and the personnel record for the employee. We could pair up a date and the diary entry or some event for that date, and so on. The first data item of the pair is called the key, so that's the person's name, the payroll number and the date. And the second data item is called the value. So that's the address, the personnel record and the diary entry which corresponds to the key date. Associative containers are very useful because you can not only store information, you can also search for it. So for example, if we have a container full of people's names and addresses, we can search for a particular name and we'll get the address for that person. We could look up an employee's payroll number and we'll get their personnel record. Or we could look up a date and find the corresponding diary entry. So these are very useful for lots of data processing and other applications. With sequential containers, we can store the data really in any order that we want to. Normally we start at the beginning of the vector or array, and then we go on and insert elements until we get to the end. If we're populating a string from a string literal, then the compiler will call a constructor for the string class, which basically does the same thing. But there's no law saying that it has to be that way. We could start at the end of the container and then work backwards, adding elements until we get to the start. Or we could even insert data at arbitrary elements anywhere inside the container. With associative containers, the data is stored in an order which depends on the key for the data. So for example, with the names and addresses, the key is the person's name, so the data would be stored in alphabetical order of the person's name. So a person whose name starts with A would be at the beginning, and a person whose name starts with Z would be at the end. With employee records, the key is the employee's payroll number, so they're going to be in numerical order of the payroll number. The lowest number will be at the start and the highest number will be at the end. And dates, obviously the earliest date will be at the beginning and the latest date will be at the end. How does the container know how to do this? It uses the less than operator on the key. So if the person name is a string, it's going to use the string's less than operator for ordering the records. With the employee number, which is presumably going to be an integer of some sort, it'll use the built-in less than operator. For dates, presumably there'll be some sort of date class which is used for this, which will have a less than operator. So if you're writing your own class, you will need to provide a less than operator if you want it to be the key in an associative container. Obviously for built-in types or classes which are part of the standard library like string, that's already been done for you. The other question is, how does the container keep its data in order? Well, every time an element is added or removed, the container will sort itself to make sure that all its data elements are still in the correct order. So this is useful if you want to be able to print out all the elements in the container and get them in the right order. However, there is some overhead because inserting or deleting an element will require the container to be resorted, which is going to take up some CPU time. It might also be the case that it doesn't really make sense to implement the less than operator for your class, so you may not want to do that. So there are in fact unordered versions of the associative containers which will store data in an order which the data structure decides is the most efficient. There's also some things which are called container adapters. These are data structures which are implemented using sequential containers. In software, an adapter means something that makes a class look like some other class. If you've done design patterns, you may have heard of the adapter pattern. These containers are basically stacks and queues, so that means they store the data in a particular order. With a stack, the data is always added or removed from the top of the stack. With a queue, it's always added or removed from the front of the queue. And with a priority queue, it depends on the priority of the data. Okay, so we'll just quickly list the sequential containers. As I said, we'll go into more detail in the following videos. So sequential containers, string and vector and array we already know about. Deck, which is a double-ended queue, and list. Container adapters are stack, queue and priority queue. And the associative containers are set, map, multiset and multimap. And also there are versions of those which don't order their keys. Okay, so that's it for this video. I'll see you next time, and meanwhile, keep coding.